Okay, this is number 14 from section 5.2. The water velocity at any point in a stream or river is related to the logarithm of the depth at that point. For the Hoback River near Bondurant, Wyoming, V is equal to 2.52 plus 1.04 log D, where V is the velocity of the water in feet per second, and D is the vertical distance from the stream bed in feet at that point. So for Pole Creek near Pinedale, Wyoming, V is equal to 1.96 plus 0.67 log D. Both streams are 1.2 feet deep at the locations mentioned. Okay, so in part A it says if you double the distance from the bed, by how much does the velocity increase in each stream? Okay, we're going to just take a look at the Hoback River, and I'll say V1 for the first velocity is when the depth is 1.2 feet. So 2.52 plus 1.04 log of 1.2, which is about 2.602. Okay, and then V2 is equal to 2.52 plus 1.04 log of 2.4, which is approximately 2.915. Okay, and it asked how much does the velocity increase? So we want to know the change in these velocities. So V2 minus V1, or 2.915 minus 2.602. Okay, and that's about 0.313. It does say round your final answer to two places, so we'll say about 0.31 feet per second. Okay, it says the average velocity of the entire stream can be closely approximated as follows. Measure the velocity at 20% of the total depth of the stream from the surface and 80% of the total depth. Then average these two values. Okay, so again, we're going to find a couple of velocities. Okay, so it's V1 is equal to 2.52 plus 1.04 log of D, and in this case 20% of the depth is going to be 0.2 times 1.2, which is about 1.875, and then to find the second velocity we're going to find a depth that's 80% of the total depth, so 2.52 plus 1.04 log of 0.8 times 1.2, okay, which is about 2.502. Okay, so find the average of these values. We have 1.875 plus 2.502 divided by 2, which is about 2.19 feet per second.